So welcome back to part 2. So we're going to continue with our Christmas Tree Bauble project. Let's have a look at some of the electronics now. So like I said, this is based around the Pimoroni plasma stick. So I've got one embedded in this test print that I did. Call it a test print, it's a failed print. But yeah, you can just see there that it's attached, and the orientation is it's actually that way up so that the USB connector can go to the top. And you can see there that we've got 3 screw terminals on the bottom. We have one for ground, one for the 5 volts, and one for the pixels, and these are out. These are to connect to the RGB LED strip. Now I'm not using strip, I'm just using these little Adafruit jewels, and the 3 wires I've just soldered onto the back of one of these 3 wires, just like a red, blue and black wire, and then they're just screwed into the screw terminal in the bottom of the plasma stick. Now the plasma stick also has a few extra goodies on here. It also has what's it called, a Quest connector. I forgot what it's called, a Quest connector. So one of the things that we can connect to the Quest connector is something like this CO2 connector, or various temperature sensors. So this is an SCD41. And you can see there it's a CO2 sensor. So if I have this plugged in, I could breathe near it and we could have the colours change depending on the sort of amount of CO2 in the air. I was actually thinking of making a 3D printable nose for this, so I might use it on a different project, but we can enhance this even more, make it even more advanced. So it's the even more advanced Christmas Tree Bauble. So a few things to note about these Adafruit NeoPixel jewels. Watch out for the RGB or RGB.py, so that's red, green and blue and a white LED that's built into the little LED package, and the RGB order. So I've been playing around with a few different LED strips, and when we come to the code in a minute, not all LED strips, particularly these ones I've been using, are RGB. They have a different sequence. They might be GRB or GBR or various combinations of that. Okay, so we'll have a look at the next slide. So this is about how we're wiring it up. Like I said, very, very simple, trivial to do this. So it probably took about 5 minutes just to solder this up. So on the Adafruit Dual example there, they've got the solder points in the middle. On this one I've got, they're on the actual edge of the device. So you can see they're on the sort of bottom edge there. There's just a couple of solder points. There we go. So it says ground voltage in, ground voltage out. So the in and out is if you have a chain of these, you can solder each of the ins to the outs, and you have a whole chain of them, and you can individually address the RGB LEDs. We're only using one of these, so we don't need to bother with the out. We just need to solder the out wire from the plasma 2040, the plasma stick 2040W to the in of our Adafruit Dual. Okay, so what's MicroPython all about? Let's have a look at the MicroPython. So I've done quite a few different projects on this. I've created a web server. This is the sort of advanced part of this. There's the Christmas tree I was talking about. And you can basically just configure the Wi-Fi _config.py in the project files with your local Wi-Fi SSID and password and country setting. And you can currently choose from 3 different modes on this. It's a work in progress, so it's not perfect yet. We'll have a look at it in a minute in one of the demos. You can have the cheer lights mode, so it will change depending on what the cheer light colour currently is. Currently green. And yep, green. And we also have a spinning light one, and we have an MQTT, so I can hook it into our Node-RED, and then I can control everything. So I could even hook up the cheer lights to control every light in my house, garden, outside, and so on. We have a lot of lights. Okay, so let's have a look at some of the code, shall we? We'll have a demo in a second or two. But just before we do that, please make sure you give this video a like. Drop me a comment if you've ever used cheer lights before, if you've built any projects, or if you're inspired to do this. And if you're going to do any sort of Christmas related projects as well. And also make sure you subscribe to this as well. It really does help the channel grow, it costs you nothing, and you'll get more great content, fresh content every single week. Speaking of which, so I do go live every single Sunday at 7 PM GMT, which we now are in because that British summertime and daylight savings is over. So we're synced up again with this slide. It's right half the year. So we're going to have a look at some demo code now. Right, so the first one, let me just get over to Thonny. I'm just going to put it on me for a second while I load up the code here. And then we can have a play. Oops. That's the one I want there. Right, so I've currently got the code just running the cheer lights code. Let's just stop that and let's run the very first piece of code, which is just called color. So let's have a look through this and let's have a see how this works. So the first thing I'm going to do is import Plasma. This is a Plasma Stick 2040W from Pimoroni. They have their own libraries built into their version of MicroPython. It's very simple to install that. You can do that through Thonny. You can just go down here, go to Configure Interpreter. You can install or upgrade MicroPython, and if you're in the you have to basically just hit the reset button on the device, and then you can choose the MicroPython variant. And one of the MicroPython variants in there is the, I think they call it the MicroPython with Pimoroni libraries. So that's the one that you actually want. Okay, so that's the first thing we're going to do. From Plasma, we're going to import the Plasma Stick, which it means it knows all about the different connectors and things that it has, and all the pinouts are defined. And I've created a little library that I've just called RGB. So let's have a quick look at RGB to see what that actually has in it. It's just got a couple of functions for doing things like RGB to HSV. So red, green, blue. Very, very simple to work with, but sometimes if you want to increase the brightness or you want to cycle around the colors, it's a lot easier to do that with hue, saturation and value. You can just change the hue value or the saturation value to make it more white or more solid color, or you can change the brightness to just increase or lower the brightness of your LEDs. So often what I will do is I'll pick an RGB color, I'll convert it to HSV, and then I will adjust the V value, the brightness value, just to bring it down a little bit so it's not sort of really, really bright. So this will convert, using a bit of math there, an RGB value to a hue, saturation and value. Now I found a bit of a bug in the code that is in the Cheer Lights library on the Pimoroni Plasma Stick. There is the hue is basically returning a value between 0 and 360, and we don't want it to do that. We want it to be between 0 and 1. So I've just had to say h equals h divided by 360 just to fix that. So I'll raise a bug report about that shortly. Let's scroll down. So then we've got another one which is HSV to RGB, so it does it the other way around, converts from HSV to the RGB values, nice and simple. And then we have some things like how do you mix two RGB values together? So you can just do this very simple math to add the values together and then return another value. So if you're wanting to fade between one color and another, you can use this mix to fade between them, and then the amount there is just what's the sort of slider between how much of one do you want. So really, really handy if you're doing some fancy things to do with colors. And then finally we've got two, which is hex to RGB. So if you have a hex color like the hashtag, and then it's usually like FF00AB, something like that. These kind of colors you see often in web programming. And also I think this is the value you get returned when you're playing with Cheer Lights as well from the URL. So you need something that will convert it from a hex value to an RGB, and this piece of code here will do that for you. And similarly, if you want to convert from an RGB to a hex, then you can just use this function as well. Okay, so that's what RGB does. So I'm using that to bring that into my my color. Let's go back here. I don't know why it does that sometimes. Let me just open that one back up. Let's double click on that. There we go. So that's the first three lines. The next we have the number of LEDs. So I'm using an LED stick which has 7 pixels on it. It's got 1 in the middle and then 6 around the outside. I'm also just having this orange color just as a default value just while I'm sort of testing it, and then I'm setting up the RGB LED strip, and that's specific to this particular component. So if you've got an Adafruit Dual, it might be a slightly different color ordering than I've got on here. I found that GRB was the correct sequence here to make the colors work properly. If you use RGB on this, the colors will look weird. They'll be the wrong color. And then you do LED strip.start to start off the code. And then if I just scroll down here, let me just move this other little window out of the way that you can't see. And here we have some very simple code. So red, green and blue, we convert that hex value, that orange value that we had above, into a red, green and blue. We then want to convert that into a hue, saturation and value using the RGB to HSV. We pass in those RGB values. We can print out what that is, just using this little print statement there. And then the reason I've done that converting is because I want to then bring the brightness down. So I've got a value between 0 and 1. So 0.5 is like half the brightness. And then what we have is a little loop that says for I in the range of 0 to the number of LEDs with an increment of 1. So that's all encompassed in that one statement there. We then set the HSV value of whatever the I is, which is the number of the LED we're currently addressing. So we'll start at 0 in the middle and then work out our 1, 2, 3 all the way around and so on. And we're passing in the hue value that we've got from our HSV color variable, which we converted from RGB earlier. We're going to pass through the saturation value, but the brightness, we're going to actually ignore the brightness that we're getting through that conversion, and we're going to use the brightness that we're specifying. So if I now go over to this view here, where we can see the screen, and we can also see, I've even got the portal colors, we've got orange, we've got blue. So let's run this code and see what happens. So there you go, that's the orange color that we looked at earlier. Now if I scroll to the top, let's just move this down a bit, and we can play around with those. Thonny's got some really weird behaviors when you're doing like a live stream. I don't know what's going on there. Right, so if I just change that to 0, 0, so it should be full red, no green and no blue, so it should be like full on red. So there you go. If I change it to the middle one, that will be 0, 0, FF, so red, green. The green should be now full on if I run this. There we go. And then if I do the last two, FF, so 0, 0, 0, 0, FF, we should have blue. There we go. And if we have mixtures of various different things, so we have like red, no greens but blue, what colour do you think we'll get? We get sort of a magenta colour. Let's try that sequence. A nice yellow, and let's just try 0, 0, oops, and FF and see what we get then. We get a sort of a, what's that, cyan colour. So there we go. Right, so what I want to do next then, that's the colour. So let's go back to our keynote for a second. So the next demo then is rainbow. So we're going to have a play around with some rainbow effects now. So let's go back over to Thonny. I'm going to open up the rainbow. Let me just find that one. I think it's actually on the device itself actually. Let me just make sure that's stopped. I'm going to click on rainbows, and I'm just going to make sure, just by making this screen a bit bigger, I'll just go over to this view for a second. I just want to make sure that the RGB order is correct. So I think it should be GRB, and let's change, yeah, LEDs are 7, so that's good. If I now run that code, we can now see that we have this nice color cycling effect. I really like this effect. I think it looks quite nice. This is probably one of the ones I'm going to have quite often when it's hanging on the Christmas tree. So that's the color. And let's have a quick look at the code itself. Let's have a see how this works. So we're doing the usual kind of imports, plasma stick. We're also importing time because we want to do some things to do with pausing every time it goes around the loop. Set the brightness again to half. We've got the same number of LEDs. We've got these speed and updates included on here. And this is how fast we want the LEDs to cycle, so that how often they change in the colours. The updates is how many times a second do we want to update them. And we're going to use them in a little formula down in a minute when we do a sleep. We then set up the LED strip, just using that same path there. So you can see there, plasma WS2812, that's the type of LED strip that we're using. We're passing in the number of LEDs. You can ignore the 0 and 0 on there. And then the pin for the data in, data out, sorry, is there. If you're using the other variants, the APA 102s, they have also a clock pin as well, but we don't need that. And then the color order, for this particular one, we're using this GRB instead. We then start it, we create an offset, and then we have this little formula here. So speed equals a minimum 255, maximum of 1. We then increase the offset by whatever the speed is divided by 2000, and then for I in range, whatever the number of LEDs is, which is 7, we then set the hue to be whatever the I value currently is, and we want it to be a floating point number, and we want to divide that by the number of LEDs, and then we set that value. And then this sleep value here, we're basically going to say 1 second divided by how many updates per second we want to use, and that gets us this nice sort of effect where it's sort of nicely spinning and bubbling around as like a rainbow effect. Okay, of course the supporters. So this is a growing list, and I'm really pleased that it's a growing list because it just means that we've got more support for the channel. So you can see there we've got Schultz Maker, our Schultz Maker, we've got Frank, we've got Dana Hoff, we've got Grumpy Scrambler, we have David, we've got Matt Hungerford, we've got Flavor of Dev, Patrick. Our members, we have Shemi, we have Steve, we have Thomas, and YouTube members. This is a growing number of people. So we've got Cheerlights, woohoo, thanks Hans. We have Michael, we have Fraser, we've got Bill, we've got Jose, Jeff, Johan. I'm not very good with my Spanish or Mexican kind of names, so is it Jose and Johan? And we have John Paul Jolly, and we've got Tom as well. Fantastic. Thank you everybody for helping me with the channel by supporting it in these ways. And if you want to see your name on the credits here, just head over to kevsrobots.com/credits and you can get yourself over here as well. Okay.